What is the world around us made of? This is a question that humans have always tried to answer. The first to take an interest in the concept of matter and its nature were the philosophers of ancient Greece. This man here, called Democritus, was the first one to formulate the idea of matter being composed of fundamental, indivisible particles called atoms. However, a few years later, this man was born. Aristotle found the idea of a world made up of indivisible particles so absurd that he rejected it. His ideas were considered more important at the time, and as a result, the atomic theory saw no development for the next 2,000 years, until the early 1800s when the English chemist John Dalton arrived. He studied the behavior of gases and formulated the law of partial pressures, observing that in a gas mixture, the total pressure is given by the sum of the pressures of each gas. This behavior suggested the existence of atoms because it shows that gases were composed of discrete particles that didn't influence each other. The refinement of atomic theory came at the end of the 19th century with Thomson, who discovered the existence of electrons through the cathode ray tube experiment. He proposed the plum pudding model of the atom, in which electrons were embedded in a positively charged mass. His student, Ernest Rutherford, with the gold foil experiment, demonstrated that the atom has a central positive nucleus, around which electrons orbit, proving that the atom is mostly empty space. He developed the planetary model of the atom. After, Niels Bohr, a student of Rutherford, theorized that electrons orbit the nucleus in fixed energy levels. However, this goes against classical physics, which stated that an electron in a circular orbit should rapidly lose energy and collapse into the nucleus. This would mean that atoms should not exist for more than a billionth of a second. So Schrödinger arrived, and thanks to quantum mechanics, he solved the problem. Now, the atom looks like this. Yes, because now it's all a matter of mathematics. In reality, electrons do not orbit the nucleus in fixed paths, but exist in orbitals, regions of space where the probability of finding an electron is highest and described by a mathematical function. This specific equation describes the hydrogen atom, which has this shape, while other atoms have these appearances, derived from the other solutions to Schrödinger's equation. So, do atoms really exist? It depends on what we mean by exist. If we think of the atom as a physical object with clear boundaries, then no. However, if we consider the atom as the best mathematical description of microscopic reality, then we can say it exists. Our description of the atom is based on quantum mechanics and mathematical functions. However, these functions have real effects and allow us to predict the chemical behavior of elements. We are mathematical equations writing other mathematical equations to understand the universe around us. Or maybe are we something more?